Hey everybody, and welcome back. This is for CSE 1300, and today we're going to talk about how to get started writing actual programs. So in the last section, we were talking about how an algorithm works and how you would go about writing logical steps that you want a computer to follow as an algorithm. And today what we're going to do is we're going to convert that algorithm into a program. So let's get started. So first off, program, software, these are all words that you're going to hear that all mean the same thing. You're used to using computer programs all the time. You use them when you run something like Chrome or Firefox or Safari, whatever your web browser is. You use them when you're using things like Word, PowerPoint, Excel, any of the Office suites. All of these are programs that somebody wrote. Likewise, editing tools for images, likewise any games that you've played, phone apps like Instagram, Snapchat. These are all programs that somebody wrote in a language that's running on your phone. Games on consoles, even embedded appliances that you might have in your house or that you may use in other ways, like toasters and projectors and TVs, they all have software that was written for them that is used to control them. So software is everywhere. You use it all day without even really knowing that you're using it. All right, so what is a program and how does it differ from software? They're the same thing. So when we say software, we're referring to a computer program. Basically, software is a set of instructions that are used to control the computer. The instructions are in a particular language, and the choice of language is often dependent on the type of hardware that we're running it on. In this case, for this class, we're going to learn Java. In some of later classes, you may learn a different language. All of the statements are executed sequentially, just like they were in an algorithm, and ultimately, you're going to convert from the programming language that you are writing in into a machine language that is what the actual computer is going to run. So what do I mean by that? Okay, so Java is a programming language. It's not English or French or Spanish or a natural language like we would use, but it is a programming language. Programming languages are meant to be readable by human beings. So most of the statements in a programming language are laid out in such a way that they kind of read like English. Not exactly, but sort of like English. And so they're for humans. The computer actually still can't understand those instructions. So what ends up having to happen is the computer has to convert everything that you write in Java into something that the CPU actually knows how to work with. So as we mentioned before in the hardware section, every computer has a CPU, a central processing unit. And this is a chip that's probably about yay big that's sitting on your motherboard in your computer. And on the bottom of it, if you were to take it out and look at it, which I don't recommend, you would see that there are about 1,200 pins either on the bottom of the chip or they're in the motherboard that connect to connectors on the bottom of the chip. But one way or the other, there's about 1,200 wires that go into the bottom of the CPU. Each one of those pins or wires can have a voltage of either 0 or 1. Right? So either there is voltage on there, in which case it interprets that as a 1, or there's no voltage on there, in which case it interprets it as a 0. And so the way that the CPU works is that certain pins are set to have voltage on them, meaning that they're set to a 1, in order to tell the CPU what particular instruction you want it to do. And an example of an instruction might be to tell it to add two numbers together. So you'd first tell it, I want to load this number into memory. Then you would tell it, I want to load this other number into memory. Then you would tell it, I want to add those two numbers together. And then you would ask it to give you back the result in another memory location. These are actually called registers in the CPU, but that's fine. All right, so the CPU ultimately needs a bunch of power turned on and off to tell it what it is that it's going to do. And if the CPU runs at 2.5 gigahertz, then it can do one of these operations about every 2.5 billion, or about 2.5 billion times a second. So the CPU is very fast, but ultimately, how does it know which particular pins to turn on and off? And that's where the programming language comes from. So ultimately, the CPU runs its own machine language, which is how many of which pins need to be turned on in order to get it to do a particular operation. And so one step above that machine language is something called assembly language. An assembly language is designed to allow you to actually write code directly at the CPU. And nobody really does this anymore. This was a thing many years ago. When I was in college, I had to learn assembly language, but even then, nobody really used it. It's a very, very low-level detail and only people who write programming languages or people who design chips would ever really write code that is direct+y executable on the CPU. So for all the rest of us, we code in a more higher level language. And so examples of higher level languages are C, C++, Java, C#, Python, PHP, Ruby, Golang, and there are plenty more, Rust, so on and so forth. You could name 50 different programming languages that exist. And you might wonder, well, then why are all these languages here? Why don't we just have one language that does everything for everybody? And the answer is, well, over time, people's needs change, and the capabilities of the CPUs change. And so sometimes it's easier to just start from scratch with a new language than it is to try and retrofit something onto an older language. And so that's why we end up with new ones every now and again. It's also the case that the languages are generally owned by a company. So, for example, C# is a Microsoft product. And so pretty much if you work in a Microsoft environment or you're dealing with a lot of Microsoft Windows, a lot of the code that you're going to write there is going to be in C# nowadays. Whereas for Oracle, which is another company, they own Java. And so Java code can run on a bunch of different types of machines, and so on and so forth. Some are more suited for working on the web, like PHP and Golang would typically be like that. Some languages are better for scripting type stuff, and that's more like Python. And then some languages are very, very low level. The closest thing to assembly code that people actually still code in is going to be C or C++. And that's because you have a lot more control over things with C and C++ than you have with Java. And again, that doesn't mean that it's a better language, it just means that if you particularly are trying to do something very specific to hardware, you would use one of those languages. But for the purposes of this class, we're going to learn Java, because it's a good starting language for folks to learn with. Alright, so each language has its own syntax. The syntax is just a set of rules as to how you must write the code. There's going to be specific rules in each language, and they're going to vary slightly from language to language. But for example, most languages are going to require that every line of code that you write has to end with a semicolon. That's not true of every language, but it's true of many, or most probably is the way to phrase it. Most languages also give you a skeleton that you have to start with, and this is a block of code that's kind of the very bare minimum code that you could possibly write to have a functioning program, and then you insert your own code into that skeleton. So these are things that are common. What you will find is that learning your first language, which is going to be Java here, is going to be a little bit non-intuitive. Some of this is going to be like, why are we doing this? It seems kind of weird to do, and it's awkward and it's difficult. And then over time it'll become more natural, and you'll be able to do it more naturally and more quickly. Once you have learned your first programming language, learning your second language is a lot easier. And it's because, honestly, most of the languages actually have very similar syntax. The words that are used in Java are very, very similar to the words that are used in C#. As a matter of fact, they're probably about 90 to 95% identical. And what I mean by that is if you took a piece of Java code, probably 90% of the time it would actually work as C# code as well without very many changes. And even when you do have to make changes, they're pretty minor. So each language is going to have its own syntax. Overall, the syntax of all the languages are actually quite similar. So learning one language is a little bit hard, learning the next one is a little easier, and then learning every language after that becomes just a lot easier. And so if you continue going down a path of learning coding, you're going to learn different languages at different times, and that's going to be true throughout all of your life. It turns out that languages are kind of like fashion, they come and go. Something that is very fashionable today may not be fashionable in 10 years, and so you may have to learn another language at that point. Alright, so how do you go about writing code? Well, you're going to use a program, which is actually something that was written in a language, but that's not important right now. You're going to use a program called an IDE, an Integrated Development Environment. An IDE is just a nice piece of software that allows you to write your code, and while you're doing it, it tries to help you with it. It tries to say, no, that's not quite syntactically right, or I don't think you knew what you were doing here, or I'm not sure that's exactly right. Because it understands the correct syntax of the language. And so in our case, we're going to use an IDE called Intellij, and it understands the syntax of Java. So if I type something into Intellij and it's not in the correct syntax, Intellij is going to give me a warning and tell me that it's not quite correct. So the first job of an IDE is to help you, the developer, to be able to write code. The second job of an IDE is to convert your code into machine-readable language. And so that's the actual thing called a compiler. The compiler is built into your IDE, and that's so that it knows how to do that automatically. The IDE also knows how to organize your files in some way, usually in the idea of a project. You're going to start a new project, you're going to put all your files in there, and then when you're done, you have a project with all of your files in it. So the IDE just helps you organize, helps you write the code, and also knows how to compile it to actually get it to machine language for you. All right, so I've used the word compile, and let me explain that real quick. So compilers have two purposes. The first purpose is that it checks your code to make sure that you have written syntactically correct code. And what I mean by that is everything you wrote in there is understandable in the language of Java. If anything in there is not understandable as a Java statement, then the compiler is going to give you a compile time error and say syntax error on line 5. Maybe you're missing a semicolon, maybe you typed in a word that doesn't make sense, or maybe it's a word that it doesn't recognize. The second job of a compiler is to take your code and actually convert it into machine code that's ready to run on a particular CPU. Now, there's a little caveat here with regard to Java. If you are writing code in C or C++, when you run a compile, it literally compiles the code to run on the particular CPU that your machine is. And what I mean by that is, I mentioned when we were talking about hardware that there's Intel CPUs, there are AMD CPUs, there's ARM CPUs, and there are some others as well. And each of those has a different set of instructions. As a matter of fact, they vary quite considerably. A CPU for a Macintosh machine or an Apple machine is going to be different than the CPU for a Windows machine. And so when you compile something in C++, if you were to compile it on a Windows machine, it would run on a Windows machine on that type of CPU, but it may not run on a Mac. You'd have to recompile it on a Mac to make the machine code that works on a Mac. So for C and C++, and quite frankly a lot of languages, that's the way that compiling works. It is specific to the CPU family that you are using on the machine that you compile it on. Java took a slightly different view of this, and they decided that rather than writing code that compiles directly to the CPU of their machine, they would put a layer in between the Java code and the CPU machine language, which they called the Java Virtual Machine, or the JVM. And so when you compile your code in Java, it doesn't compile it all the way down to a particular CPU, it compiles it down to a middle ground that they call bytecode, which is code that's designed to run on the Java Virtual Machine. And then separately, the maintainers of Java produce Java virtual machines for every type of hardware. And so, for example, if you take your phone, it runs a Java virtual machine mostly. If you take your Windows machine, it runs a Java virtual machine. A Mac runs a Java virtual machine. And so if there's a Java virtual machine installed, or a Java runtime environment, which is the other name for it, then you'll be able to run code that has been compiled down to that intermediate layer. The advantage of this is that it means that if I write code in Java on a Windows machine, you should theoretically be able to pick up that exact code and run the same code on a Mac, or run the same code on an Android phone, or run the same code on any other machine that has a Java virtual machine installed. So it makes the code more portable. There is a downside to it, which is because there's that middle layer, Java code runs ever so slightly slower than C++ code or C code. So there's a slight performance hit for doing this. So it's a question of portability versus efficiency or speed of the code running. And for the purposes of this class, we care more about the portability than we care about the exact performance. But if you're writing something where fractions of milliseconds matter, you might be better off to write that code in C++, because it will be more quick to execute. All right, so as I mentioned, the Java Virtual Machine is also known as the Java Runtime Environment, or the JRE. We're actually going to see that in a few moments when we open up Intellij, because we're going to have to install a Java Virtual Environment, or Java Runtime Environment. Okay, so how do you go about writing your first program? Because we've been talking a lot and we haven't done anything yet. Well, the first step is you're going to need your IDE. So you're going to have to download it and install it. The second thing is you're going to need a Java runtime environment. So you're going to have to download that and install it. Then you're going to open a new project. It will give you a skeleton to start with, and you're going to start writing your code in there. All right, so let's take a look at each of these steps. All right, so the IDE for this class is going to be something called Intellij. And Intellij is a free piece of software that you can download, at least the community edition is free, which is what we're going to use. And you install it on your machine. It will run on Windows, it will run on Mac, it will even run on Linux if you're on a Linux machine. And then once you have installed it, that's what you will write your code in. The other possibility is replit, which you used in an earlier project when you were doing the HTML stuff. You can actually use replit to write Java code as well. And for most of the examples that I'm going to do after this video, I'm going to probably use replit myself. You can do either one. Java code that is written correctly would compile in replit. It would also compile in Intellij. There would be no difference. So whichever one is easier for you. If you're on a Mac or a Windows machine, I'd probably just install Intellij. If you're on a Chromebook or you're on something smaller like that, then replit, and that's why I use it, because I usually teach on Chromebook. There are many other IDEs, just for the record. Even for Java, there are many other IDEs. You can actually do it in Visual Studio. There's a program called Eclipse. There's a bunch of other IDEs that exist out there. And over time, you may find that you like or dislike Intellij, which is a very common one these days. So it's not, we're giving you a decent one to start with. But over time, some people like one thing or another. So after the class is over, you can certainly try other IDEs. But for the purposes of this class, you're either going to use Intellij or you're going to use replit. All right, so how do you get Intellij? Well, it's made by a company called Jetbrains, and there are two versions of Intellij. So you have to be very careful when you go to download it. You're going to be looking for the community version, which is the free version. So generally what's going to happen here is you're going to open up an IDE, or sorry, a web browser. Okay, there we go. And you're going to say download Intellij. And that's going to bring you to the JetBrains site. And when you come here and you click on that, what you're going to see is there will be two options. One which will say free 30-day trial. That's not the one you want. The other one will say free, built on the community version. And that is there. You also have to accept their cookie in this download window. All right, so this is the one you're going to hit. It's going to download about a 500 meg file, so it's going to take just a moment to get that downloaded, and then you're going to let it install on your machine. Once it's done installing, you're going to open it up, and it's going to look something like this when you first open it. All right, and so this is the main welcome screen in Intellij, which allows you to open up the new project, and that indeed is what I'm going to do. So I'm going to click New Project. There we go. All right, now when you do this the very first time, this box up here, which for me says OpenJDK 17, is probably going to have red writing that's going to say no JDK. And that means that it doesn't have a Java virtual machine or it doesn't have a Java runtime environment, so you're going to need to download the Java development kit, which is a JDK. All you have to do is click the red text that says there is nothing there and click download JDK, and it will do the rest for you. It will take it another couple of minutes. It will download it. It will then take it another few minutes to say that it's building some indexes. It's going to do all of that automatically for you, and you'll eventually end up back on this screen where it will say OpenJDK probably 17. If you're watching this later on, maybe that has incremented to a newer version, but as long as it says something like OpenJDK, you'll be fine. All right, so that's a one-time thing. You'll never have to do that again. On the left-hand side, you're going to choose the language that you want, which is going to be Java. You don't have to check any of these checkboxes. You're just going to hit Next down here. And then up at the top, you're going to say, I want to create a project from a template. And you're going to choose Command Line App, which is the only thing in there, because what you're building is a Command Line app. So we're going to hit Next. And it's going to ask you to name the project. So I'm going to call it My First Project. Call it whatever you want. And you can leave everything else as the default, and you can hit Finish. And when you do that, you can see it's going to run here for just a moment, and then you're going to end up in the main Intellij window, which looks something like this. All right, so we're just going to give that a second to figure itself out. You can see down at the bottom, it's doing scanning files and stuff, so it's doing a little bit of work still, getting itself sorted out. Okay, and now it has finally fully loaded. So Usually what you're going to see here is on the left-hand side, you're going to have the files. And so any file that you're working on is going to be over here. On the right, you can see that the name of the file that I'm working on is called main.java. And that's what it called the file by default. Where is that file? Well, it's in my first project under a folder called SRC, which stands for source code. And in there, you can see there is a main file, and that corresponds to this main.java. If I were done coding and I wanted to turn something in, that's the particular file that I would need to turn in. And you can see that here on my Windows machine, it says that's located in C:users defn Intel or IDEA project, my first project. And if I were to open up the file explorer and dig my way into that particular folder, I would find in there an SRC folder, and inside of that I would find the main.java, which has this code. So that's how you navigate files within inside of Intellij. All right, so let's go back over to the slides here. All right, so that's what the main page looks like. This mentioned how you might have to download the SDK and install it, and this is how you enter in the name of the project that you want to work on, and you hit finish. All right, so the left side is the files that you're dealing with. There's some external libraries that you're not going to have to worry about. Don't worry about scratches and consoles. My first project is the name of the project that I called this when I opened it, and that's why it's called my first project. And again, inside of there, I have the main file. On the right-hand side here, we have the actual window in which I will code. And it already filled in some information for me. And this information is a little bit weird. It's covered in the slides, but I'm just going to verbally speak through it, and then I'll show it to you back in the slides again so that you have something to reference. But this is the skeleton that it puts in there for you. It's the bare minimum amount of code that has to exist in order for a Java program to run. So there are particular things in here that you're going to pretty much just want to memorize right now. You're not going to have any real idea what any of these things mean for a while, but over time you'll get to understand each of the various bits. But for now, you would pretty much want to memorize the code that I have highlighted in blue, which is public class main, open a curly brace, public static void main, string, square brackets, args, close a parentheses, open a curly brace, and then close a curly brace and close a curly brace. All right, so that is the skeleton that you would use in Java. And again, I understand you don't know what any of that means, and that's okay. You don't have to worry about that. We'll get there over time. But it is the code that you would need to memorize because you'll need it every single time you start a new project. Intellij will fill it in for you. Replit will fill in something very similar for you. It will actually add in an extra line in here that does a print of hello world, but other than that, it has the same exact code in there. So, all right, so let's talk through each of these different things. So the first thing up here is really weird. It says package com.company. All right, on the screen where you gave the file name when you were doing the setup a few moments ago, it asked you for the name of the project, and at the bottom it asked you for the package name. It automatically filled in com.company for you, which is a really weird thing to do. So let's talk about what a package is, and then let's talk about why it called it com.company. A package, like its name suggests, if you were not thinking about computers and I said to you, I have a package for you, you would think that I have a box with some stuff in it. That's typically what it is. When you order something off of Amazon or an online retailer, typically it comes to you in a package. You open the package, you take out the things that you want out of it. It is a group of things that are put together as a package. And just as that name suggests, the same thing is true in Java. A package in Java is a bunch of Java files that are being put together to accomplish some bigger process or task or something that you would want to do. For the purposes of this class, it is never going to matter what you call the package. It's never going to matter even if you put the word package in there. As a matter of fact, if you took that line out, everything would still work the same and you would have no actual problems. So this is a line that kind of doesn't matter for now. At some point in the future, you will see at some point in the future, you will understand why you would need to do that. Okay, so I did test that, and it looks like Intellij does require that it be there. So Intellij doesn't want you to take it out, so I would say just leave it in. Don't worry too much about it. So why did it call it com.company? Well, normally a package would be set up per company. So if you worked at Microsoft, this would probably be com.microsoft.office or com.microsoft.sql server or com.microsoft.windows OS or something like that. And so it's a group of things that are all related to each other that would be a product that the company understands, and each company would have their own ones. Com.company is just generic, it's just a name that was made up randomly for it. Alright, so that's what's going on with this package. Pretty much, don't worry about it, don't mess with it, just leave it up there. You could change the name if you really wanted to, but don't. Alright, the next line of code is public class main, and then there's an open curly brace. Now specifically when I click on the curly brace, notice that it changed color. I'm just going to click off it again. Notice that it became yellow when I did that. And you can see that the curly brace matches with another curly brace down at the bottom. This is the opening curly brace, and that's the closing curly brace. You're going to see this a lot in code. Usually what it means is that you have two curly braces that surround a block of code. And so everything that's within this set of curly braces is within the class called main. There's another one of these right here where you can see that there's another set of them, and again, in this case, they're surrounding the code that's in public static void main. So almost every class, every method, which we haven't talked about yet, but this is an example of a method, and many other structures are going to have an open curly brace and a closing curly brace that delineates the block of code that they are controlling. So get used to that. It is important that you're using curly braces, not parentheses, not square brackets, not angle brackets like you were using in HTML. These are curly braces, and they're on a key on your keyboard, usually above the Enter key. All right, so let's talk about public class main. The details of this are not important right now, and they won't be important for you, at least in this class, but if you move on to another programming class, you'll learn about how you can write classes. In general, Java has to have at least one class. It generally is called main if it's not called something else. It's generally called main, which is just a generic name. You could have called it anything that you want to call it. But there has to be at least one class. This is because Java is what's called an object-oriented programming language. And class main is how they're defining an object called main. The details of that are not important, but effectively this is creating a class called main, and that class happens to be public, which again, not something we're going to talk much about right now. We'll come back to it later on. Inside of public class main, we have this public static void main, which main here is a lowercase main as opposed to main up there was a capital main. Does that mean something? Yes, it does. Capitalization is going to always be important when you're dealing with code. And so the capital main and the lowercase main are actually two completely different things. They just happen to both be called main. You will always have to have a main method. This is a main method where your code goes. It's actually how Java knows where to start executing your code. It's possible that there could be thousands of lines of code in here, maybe even millions of lines of code. So the question is, how does Java know where to begin? Where is the beginning of the program? If you remember when we talked about algorithms and we talked about pseudocode, we said every block of pseudocode has a begin main and an end main. The equivalent in Java is this main method, and the begin main is effectively this curly brace, and the end main is effectively this curly brace. So it is the block of code that goes between these two that is effectively our main program. All right, so you're going to just memorize public static void main. The details of what each of those words mean are not something we're going to cover right now. In the next class, we'll talk about strings. We won't really talk about these angle brackets for a little bit, or these square brackets, I mean, but you just need to memorize those two lines of code. They are where your code begins. All right, so I'm going to go back to the slides real quick, and we're just going to flip through the ones that I just covered. So that's the skeleton. These are the, so we didn't talk about this, but let's talk about this real quick. So right where you have the package line at the top, you could also have some import lines. Sometimes you need Java to use code that somebody else has already written as a library. So I might write code that's a library that deals with being an instructor, and it has all kinds of things that are useful to other instructors. If somebody wanted to use my code, they could import my library. And then once it's imported, they have access to all the same code that I've already written. They don't have to rewrite it. So libraries are things that you will sometimes see at the beginning, and they're done with import statements. So up here where there's a package, you could have an import statement, and it would look like import java.util.scanner. That would be an example of a package in an import, and that would bring in all the things that are in scanner, which again, not something you really understand or know about, but it is possible that might be something you need later on. All right, we talked about packages, we talked about the class main, and we talked about the method main. All right, so that brings us to this line of code. So this line of code begins with 2 slashes. And there's something else that you should notice here, which is if you look at all the rest of the code, it's very colorful. The IDE Intellij is color coding things to orange. This one looks like it's kind of, I don't know about yellow, but it's certainly a creamy color. These are white, but this is gray. It's grayer than everything else on the screen. Okay, this one is also gray. There's a different reason for that. All right, so what's going on down here? Well, this is what's called a comment. A comment is when inside of your code, you want to write something that Java is not going to understand, but it's a comment to yourself. So I could say, this is a program that is going to say hello. That's not Java code. Java does not understand anything about what I just wrote there. That's a line of information that is just for me. And so effectively, if the line begins with two slashes like this, what you're telling the compiler to do is to ignore everything that comes after that on this line. All right, and so for just that one line, the compiler ignores it. Now you might say, okay, why would I want to write code that the compiler ignores? Isn't the whole point of writing code that I have code that the compiler compiles? And the answer is yes, mostly. But sometimes when you're writing code, you'll want to be able to leave a note to yourself to say, this is something that I'm going to work on later, or I need to remember to fix this, or this code is going to do something very particularly complicated, and I want to explain to myself and to anyone else later what I'm doing. And that probably seems really weird to you right now. You're thinking, I'm sorry, why would I write an explanation in my code to explain to me what I'm doing? Well, you're going to find that when you write code, if you come back and look at it a couple of weeks later, you may not be able to remember exactly why you wrote it the way that you did. And so a comment, which is what this is, allows you to tell your future self what it was that you were doing. There are a number of things that you probably don't remember. Like if I take a physics formula or something like that that maybe you're working on, or a chemistry formula or biology formula or anything like a mechanical engineering formula, any formula that you use, you probably don't remember it all the time. You probably have to go look it up most of the time that you use it. And so if you had written code to implement a formula, you might forget what it is that you're doing in that code, because by the time you get in there and you're actually doing the sums and the divides and the multiplies, all of a sudden you're going to have a hard time remembering why you're doing any of that. And so a comment would be a way that you can help your future self to understand what's going on. For the purposes of this class, you're going to write comments so that we can tell who wrote the code. So usually at the beginning of the code, we're going to ask you to put a comment with your name up there and maybe some other information. So it might look something like that. Or something like that. So any line that begins with 2 slashes is a comment. It is ignored by the compiler. It is purely for a human being to read and to understand what they were trying to tell you. You will want to use comments in your code because over time you're going to find that it's going to be hard to remember what you were doing. All right. So this slide talks about the curly braces. And one thing that you're going to find with curly braces is anytime you open one, you need to remember to close it. So there's an open for main here and a close for main there, an open for the main lowercase m here and a close for it there. And you might say, well, how does it know that this one corresponds to that one as opposed to this one corresponds to that one? Anytime you have a closing curly brace, it closes the closest opening curly brace. So it is absolutely the case that the two that are highlighted here are open and close of each other, versus the two that are now highlighted are open and close of each other. So it's not the case that this one is closed here, it's closed all the way down there. So as you write code, anytime you open a curly brace, you're going to need to remember to close one. And actually, this is one of the ways in which the IDE is going to help you. Anytime that you open a curly brace, it automatically is going to try and give you the closing one as well. So it's going to try and help you in some of that. All right. So that's curly braces. Make sure you always have a close for every open. All right, so let's make our first change to this program. So underneath where the comment is, I'm going to write this particular line of code, which, again, not something that you're going to really understand right now, but we're just going to type it. So system.out.println hi, and a semicolon. All right, so there's a couple of things happening here. I'm always ending lines with semicolons. You'll notice that it colored that the same color as some of these words, whereas the rest of this ended up being colored either gray, purple, or green. So these are colors that we haven't really seen before, and each of these things has a particular meaning, and that's why it's color coded. If you're writing this on your version of Intellij at home, the particular colors that you get may be different because they're based on a theme. So if you do this in Intellij versus replit, if you do this on a Mac versus Windows, if you do this on any different version of Intellij, the particular color you see may change, but the same things will be colored the same way. So don't worry about the particulars of the color, just notice that the colors are changing for different types or different parts of the code. All right, so what have I told it to do? What this is telling it to do is to print out onto the screen the word hi. All right, now how do I know that that's what it's doing? Well, the first thing to mention here is that all of this code has to be typed exactly as it was in the other screen. It's important that this system is in a capital letter and all the rest of it has lowercase letters. It's important that this is a period and that there are no spaces before or after that period. It's important that that's out with lowercase, and it's important that this is PRINTLN, all lowercase. It's also important that there's a set of parentheses, and these are regular round parentheses that are at the end here, and inside of it it's important that hi is in double quotes. So why is all of that important? Well, let's run it and let's see what happens. The way to tell Intellij to run your code is up in the top corner of your screen here, there's this little green triangle. And so if I press that green triangle, a couple of things are going to happen. The first thing is that the compiler is going to try and compile this code. It's going to try and understand it and make sure that it's all correct. And then once it has succeeded in that, it's then going to run the code. So I'm going to press the button, and you can see down at the bottom underneath the window where my face is, down there, it says build. And you can see that right now it's running a build. The build is another word for compile. It's parsing my Java. It says it's finished. And now we get a new window, and in that new window over here, it says hi. All right. At the top of that window, it says all kinds of crazy things. It says user-defined, OpenJDK, bin, java.exe, mine a Java agent, blah, 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 blah. There's all kinds of crazy stuff in here. If I scroll over, you'll see even more of that. That's just the command that it actually ran to execute my Java code. Don't worry about it. The output of my Java code was this word hi. And then Intellij told me the process finished with exit code 0. Now that's a weird thing to say, but exit code 0 means success. Success means that it completed running the code and it didn't run into any problems while it was doing it. Bizarre that it's 0 to mean success, but it is 0 to mean success. Now, what would have happened if there was a syntax error? I'm going to take out this semicolon, and I'm going to hit run again. Now, again, you can see it's building down below the window down here, over there, and you can see that it's still working, but now all of a sudden my window has come differently. Instead of seeing the word hi, you can see that I got an error, and the particular error says main.java :12:33 semicolon expected. Now what does that all mean? Well, it's in the file main.java, which again is the name of this file, and it says that the problem happened on line 12. And you can see on the left-hand side here, it numbers all of the lines of code. So it's telling me that the error happened here. The 33 is actually telling me that it's the 33rd character where it thinks there should be a semicolon. So it's actually very specific. It realized exactly what was missing and where it should be, and the error message that I got was semicolon expected. So this was a compile error. Because this was not syntactically valid, this is not good Java code. The compiler said, no, I'm not happy with it, you need to fix this code. You'll note that it didn't run, I didn't get the word hi on the screen anywhere, it just said there's a syntax error. So an important lesson here is, when you write code and you compile it or try to run it, which is what you're doing up here, you're trying to compile and then run, the compile could fail, which is what happened here, because of a syntax error, and then the run never happens. So if you're trying to figure out why your code isn't running, it may be because you're getting a syntax error. And you may get more than one syntax error. This was one error. So I'm going to do this. I'm going to take away one of the closing double quotes. So remember, this used to be hi double quote, double quote hi double quote. Well, I'm taking away one of them. And again, I'm going to hit compile. And you can see again, I'm going to get a syntax error. And in this case, it's a different error. It's still on line 12. This time it thinks it's around character 28. And the particular error that it gave me is an unclosed string literal. So it can tell that I opened something, but I never closed it. And if I were to take away this semicolon off the end of the line, you're going to see that I'll actually get at least 2 errors. I think I will at least. Let's see. Okay, well, I actually don't, because it's not able to see that. I'm going to put another line up above that. I'll just do another system.out.println. line. I'll do hi again. All right, this time I'm going to forget the semicolon on the first one and the double quotes on the second one. So let's see if I can get 2 errors this time. There we go. So you can see on the left side, it now has 2 exclamations. One of them is that there's a semicolon expected, and then if I click the other one, you can see it says unclosed string literal. So it's possible that you can have more than one error. I'm going to fix both of these. I'm going to put the semicolon back there. I'm going to put the double quotes here. I'm going to put a semicolon back there. I'm going to hit run again. And now all my syntax errors are gone away, and you're going to see that it's going to print out hi again, and then hi. And that's because I now have 2 print statements in here. The first one prints hi again, and there it is, and the second one prints hi. And I get that those are out of order, but that doesn't really matter. Okay, one more important lesson is, on line 13, I'm going to take this double quote back out again, and I'm going to take out the semicolon on line 13. When I compile this, you will notice this is a case where Java can tell there is a problem with the double quotes. It doesn't really know that there's also a problem with the semicolon. And that's because the first problem hides the second problem. So it's not telling me that there's a semicolon missing here right now. It's because right now it doesn't know about where the double quotes close, and so it doesn't know if that parenthesis is part of the string, which don't worry about what a string is yet, but it doesn't know how to read that, so it's a bit confused. So even when I put in the double quotes here and I hit compile, you're still going to see that it still has a problem, but now it's a new problem, and that's a common thing. So when you write code, it's not uncommon that you're going to make a mistake. You're going to hit compile, it's going to tell you that there's a mistake, you're going to fix that mistake, you're going to hit compile, and it's going to tell you that there's another mistake. So don't get frustrated, just work your way through the individual problems and figure them out. And again, you can tell line 13, it's telling me there's a semicolon missing, so it should be pretty good. The last thing I'll mention is that if you look very carefully at the code window, you'll notice that Intellij has actually put a little red squiggly line right above where I have the cursor there. And that's because even before I hit compile, Intellij knew that there's a semicolon missing there. And so it's highlighting that spot, and as soon as I put it in, notice that the red squiggly line went away. And likewise, when I take out the double quotes here, you notice that Intellij underlines the whole thing now, because it's like you opened a double quote, but you never closed it. So Intellij and also replit, they'll both do the same thing, are going to try and help you as you're coding, even before you hit the compile button, to fix the problem. And once you fix it, you can see that goes away. So just a couple of things to help you get through compile errors. You're going to get compile errors all the time. Don't be worried about them. It's free. The compiler is going to just tell you what's wrong, or it's going to give you a weird error message and you're going to have to figure out what's wrong. But it's okay to try and try again. That's kind of how this works. All right. So let's see. All right, so when you hit that green button, Intellij compiled your code, It checked to make sure that there was no syntax errors, and then assuming it had no errors, it went ahead and executed your code. When the code finished, it printed out whatever the code told it to do, and then the program finished. And if I were to hit the green button again, it would do the same thing again. And what I mean by that is, now that the code has been compiled, when I hit run again, it doesn't have to recompile it because the code hasn't changed. It simply just has to run it again. And so if I hit that little arrow again, you're going to see it's just going to run it again and run it again. And you notice it's faster at running it now than it was before. It's because it realizes I haven't changed the code. But even a trivial change in here, even if I were to put a space right after this and then hit compile, now it's got to recompile it again and make sure that that's still syntactically valid and that it understands what to do. And you're going to see it's going to go through the compile process, and now it runs it and it says, yeah, you're okay. So compiling is one step, running is another step. Compiling only has to happen when you change the code. Running happens anytime you want to run it. And so if you think about running an app on your phone, usually what's happening there, you're not compiling it, that's already been done long ago, you're just running it. When you open up Snapchat, you're running the program Snapchat. The code has already been compiled and it's already correct. They fixed that at the time when somebody working at Snapchat went ahead and made the changes that they wanted to make and shipped out the new version to you that you downloaded through your App Store or your Play Store or whatever you have. All right. Let's see what else we're going to talk about here. All right, so why did the computer say hi? Well, simply because I told it to. So in my code, I'm going to take out this line completely. I'm just going to go back to this one line. So when I run this, the only thing that I get is the word hi on the screen over here. And that's because that's literally what I put inside of these curly braces. Specifically, the things inside the curly braces are also inside double quotes. And the technical term for anything that's in double quotes is a string. A string sounds complicated, but it really isn't. It's just a set of characters that happen to be next to each other that are related. And so if I change the string to bye, and I run it again, then it'll print the word bye on the screen instead of printing the word hi on the screen, because that's what it's told to do. So a string is something that you can write that has multiple characters. It can also have spaces, and it can be a big long sentence. This is a long okay, and now when I run it, it's going to print all of that out onto the screen. All right, so a system.out.println seems to be a command that makes Java print something on the screen, and that is indeed what it is. As a matter of fact, we're going to break it down into its three different parts. So the first part, system, refers to the operating system, which in my case is Windows, because that's what I'm running on here right now. Some of you may be running on a Mac, some of you may be running on a Chromebook. So system refers to your operating system that the code is running on. Out refers to Java is sending something out of the program. Typically, out refers to your screen. It's putting something out onto your screen. And this is the screen down here. And then println is a command in Java that says, I want to print a line of text. Now you might be thinking, you keep saying print line, but that's not actually what you typed. You typed println, and it's just an abbreviation. So println is the command. It's meant to be print a line or print line. They just abbreviated it to println so that you didn't have to type such a long sentence. So to my operating system, I want to put something out onto the screen, and I want to do that as a print line. And the line that I want to print is, this is a long sentence, my name is N. And then the end of that line is a semicolon to say I'm done with this line of, or this command effectively. And now the next command goes on the next line. And again, I could have another system.out.println. This is another line, and then that needs to have a semicolon to finish it up as well. And so it'll do the first print line, and then it will do the second print line. And what I'll see on the screen is, this is a long sentence, my name is Enda, this is another line. I get both of the lines out. So println is the first command that you now know in Java. And yes, it's a little weird, and you have to remember system.out.println in order to make it work, but you can have a program that prints anything you want it to print. You can have as many of these commands as you want in there. This is a third line, and so on and so forth. I could have 5, 10, 1,000 lines. I could be printing stuff out onto the screen all day long. I could print an entire book onto the screen if I wanted to, using system.out.println. You'll notice that I left a spare line in here, but it didn't appear over here. Why is that? Well, because each of these are commands to Java, and each of these is telling you to print one line of text. So it does this line, then it does this line, then it does this line, but nothing told it to print a blank line. If I'd wanted a blank line on the screen, I'd actually have to say system.out.println, and I can just open close parentheses, because I don't want it to actually print any text. I just want it to print a blank line. And now you'll see that there will be a blank line in between these two when that program compiles and finishes. So if you want a blank line, you got to tell it to print a blank line. The great thing about computers is they will do exactly what you tell them to do. The terrible thing about computers is they will do exactly what you tell them to do. So if you tell it something wrong, it's going to do the wrong thing. So nothing bad happens. You're never going to break it. Don't worry about it. Just try something else and see if you can make it do what you want it to do. So that's what the system.out.println does. As I mentioned, for things that are in double quotes, which in the case of this is a third line, that is called a string. A string is nothing more than a sequence of characters that are smushed together. The string has to start and end with double quotes. And you will notice that in my version of Intellij on my particular operating system, it's color coding all strings to be green, which is different than all the other colors. Every version will do something similar. Your version may not be green, but it will certainly color code all the strings to be one particular color. So you've seen a string. We'll talk a little bit more about what those are in a later class. But a string can have a word, a character, a sentence, a paragraph, or anything bigger than that even. A string could have many, many lines of code in there. All right, we mentioned what system.out.println does. That's basically just for getting information out onto the screen. All right, so now it's your turn. Try to make a program which writes on the screen 3, 2, 1, lift off like that. All right, so you should pause the video and see if you can go do this in your version of Intellij. So I'm going to pause for just a second. Now I'm going to assume that you have unpaused, and I'm going to go ahead and show you how you would do that. So in Intellij, what we're going to write is, I'm going to get rid of all these statements that I have in here right now, and we're going to start off from scratch again. And I'm going to do system.out.println 3. And then 2, 1, lift off. All right, and if I run that, I should get the correct output. 3, 2, 1, lift off. All right, so it's just 4 different print statements. There are other ways that you could solve this, and we'll look at those as we go forward with some other commands, but that would get you the output that you're looking for. All right, so the last topic that we're going to talk about today is the difference between a print and a print line. So we've only so far used the command print line. So I'm going to change my code over here to, instead of being system.out.println, I'm going to change it to system.out.print. So I'm just taking away that weird ln off the bottom, and I'm going to run the same code. Now, before I run it again, I want you to look at the original output. There was a 3 on a line by itself, a 2 on a line by itself, a 1 on a line by itself, and the word liftoff on a line by itself. There were 4 lines of output. Now when I run it, having taken away the print line and changed them all to prints, what I instead get is 3, 2, 1, liftoff. Okay, so I think you can probably guess what the difference between a print and a print line is. When I do a print, it simply prints out the thing that I told it to print, and then it stops. When I do a print line, it prints out the thing I told it to print, and then it does a carriage return, or effectively it hits enter to move on to the next line. So a print versus a print line, if I intermix the two of them, which I can absolutely do, I'm going to change this one back to a print line, and I'm going to run it again. What's going to happen is it's going to print out the 3, and then the 2, and then the 1. But after the 1, it's going to do a carriage return, so the liftoff is back on the new line. So we have 3, 2, 1, they're all on the same line, but because I did a print line for 1, at the end of the 1, did a carriage return that brings you back to the beginning of the next line. And so now when it prints liftoff, it ends up on a line by itself. It's a little non-intuitive, but you would kind of think that you'd put the print line in liftoff, not the print line in 1 in order to get this output, but it happens at the end of the print. So it prints whatever you tell it to print, which in this case was 1, and then it does a carriage return. That's what the print line gives you. So that is outputting a print versus a print line. And so actually you can see that's the same output there. All right. So that is the end of today's lecture, and this is just talking about how to go about getting started and writing some of the most basic code. You should definitely practice, and I want to reiterate that as you are coding, things are going to go wrong. You're going to get errors. Those errors are going to be frustrating sometimes. You're going to have a hard time sometimes even understanding what the error is, but you just need to go back and look at the code and make sure that it is exactly the way that you think it is. If you're following along in these slides and you're getting some weird error, the chances are you misspelled one of these words, or you put a different capitalization on one of these words, or you forgot a semicolon, or you forgot a quote. Double check to make sure that it's exactly the way that you think it is. All right, so that ends today's lecture, and in the next one we're going to talk about variables. We'll see you then.